We know that objects, when they move at a certain velocity, they have a momentum. But what happens when an object changes their velocity over time? If an object changes their velocity, in other words, we have an initial velocity and a final velocity, uh, we can say that an object that has a change in velocity has what we call a change in momentum, or delta p. So the triangle just tells us that there is a change in momentum. In real life situations, this can happen where an object can change speed over time, and doing so changes momentum. Um, Note that the change in momentum can be solved by taking the object's mass times the object's change in velocity. And you know that change in velocity is the same thing as saying velocity final subtracted by velocity initial. All of this constitutes the change in momentum. This might be an equation that you might need to know, so I would highly suggest you know this. Now, in regards to this, because there is a change in momentum, or sorry, a change in speed as shown here, um, the primary cause for the change in velocity or change in speed is acceleration. Now you notice that from previous kinematic equations, the acceleration of an object can be taken as the object's change in velocity over change in time. And so basically any object that changes velocity obviously has some form of acceleration. Um, if we take this equation and rearrange it, you'll notice that we can actually plug it into the momentum equation. Let me give you an example. Let's go ahead and rearrange this equation so we can get change in velocity by itself. The only way to do that is to take the change in time and multiply it on both sides. Doing so, you'll get an equation that says change in velocity equals acceleration times the change in time. And what we can do with this part is we can substitute this change in velocity with acceleration times change in time. So in other words, we will get an equation that looks like this. So this is our equation. Change in momentum is equivalent to an object's mass times the object's acceleration times change in time, where this basically came from this change in velocity, which is literally that stuff right there. We can substitute the change in velocity with this equation. Now you'll notice that once the equation is set up like this, you'll notice that mass times acceleration equals the object's force. And if we just bring down the change in time, then we have set up a new equation that looks something like this: force times the change in time, which essentially, when you put these two together, this constitutes for the change in momentum. But more importantly, this constitutes a new term that we are going to introduce as impulse. Impulse is a term that quantifies the overall effect of an object that has a force that acts over a certain amount of time. And the symbol that we use for impulse is J, and we use the equation to solve for impulse as force times the change in time. Now, as you notice, this equation here, which equals impulse, also equals the change in momentum. And you'll notice that this equation here also equals the change in momentum. In other words, what we're trying to say is these two equations are also related to each other. We can actually put both of these equations in one equation, and we can form what we call the impulse momentum theorem. The impulse momentum theorem, where an object's force times the change in time equals the object's mass times the object's change in velocity, which you can break down the change in velocity as velocity final subtracted by the object's velocity initial. And so this might be Another equation that you might need to keep in mind when you're solving questions regarding momentum and impulse. Note that you can take an object's force times time and equate that to the object's mass times velocity final subtracted by velocity initial.